discuss the forces of attraction between molecules. I've got those three forces written in boxes. That is going to come down to, is the molecule polar or is the molecule lopsided? So we talked on a previous slide that a polar molecule is going to act like a magnet. It's going to be attracted to other molecules like it, and so we just call those attractive forces. So are there attractive forces is the same question as is the molecule polar. If it's not, if it's a symmetrical molecule, for example like hydrogen or CH4, something where all the atoms around the central atom are the same and there's no lone pairs, then that molecule is nonpolar. So there's a very weak force of attraction called the dispersion force, and that's due to the fact that electrons are always moving. So for a very short time period, the electrons could be on one side of the molecule, but it's not permanent. So this is kind of like taking a paperclip and making it a magnet. It's not a magnet for very long, and it's certainly not a strong magnet. But this nonpolar compounds, this is the only attractive force in nonpolar things. So it's not very strong. So the dispersion force is the only force of attraction in something nonpolar. And again, that would be like CO2, CBr4, a molecule that is perfectly symmetrical with no lone pairs on the central atom would be nonpolar, and therefore it would have the dispersion force only. Now, if the molecule is polar, then that's lopsided. So polar means it has lone pairs of electrons on the central atom, or the central atom has different things bonded to it. So now we're going to have to make the distinction on how polar is it. How strong is that attractive force? So normal polar versus very polar, that's not very technical. But something that's very polar has a special name called hydrogen bonding. And that's just very polar, and it's called hydrogen bonding because this type of force has to occur between hydrogen and either a fluorine, remember that has an electronegativity of 4.0, or a hydrogen has to be directly bonded to an oxygen, and oxygen's electronegativity was 3.5, or hydrogen has to be directly bonded to a nitrogen. So the three most electronegative atoms, starting with fluorine, those are in the top right-hand corner of the periodic table. So right here, you don't have to do a whole lot to remember that. But fluorine is the most electronegative because it is a bully. It pulls electrons toward itself, and then oxygen, and then nitrogen. So remember, hydrogen is the wimpy guy. So hydrogen has to be directly bonded to one of these three bullies. And if that's the case, then we just have a very lopsided molecule. Now this nitrogen probably has other things bonded to it, maybe other hydrogens, and the same with this oxygen. There would be something over here on this other side, maybe a carbon with some hydrogens around it, maybe another hydrogen. That would give us water. And when hydrogen is directly bonded to fluorine, fluorine's already happy like that, so that would be the way that the only molecule that we would see hydrogen directly bonded to fluorine. That bond would be the molecule. In this case, we would have water. Here is where the hydrogen bond is. Technically it's not a bond, but because hydrogen has to be one of the atoms involved in the molecule, we call it a hydrogen bond. So when we are looking to see what types of attractive forces a molecule has, we want to look for a hydrogen bond. You want to look to see if hydrogen is directly bonded to fluorine, oxygen, or nitrogen. If that's the case, we have a very, very polar molecule and a very strong force of attraction. Okay, so this is the strongest attractive force. Normal polar would mean if a molecule is polar, for example, and the hydrogen, if there is one, it's not directly bonded to an oxygen, nitrogen, or fluorine. So this molecule is lopsided. So this would be polar, or HCl. That's lopsided because it has two different atoms. Okay. Or we could have a carbon with two hydrogens around it, and something else like iodines. So the fact that this molecule is lopsided means that it's polar. If nitrogen, or any molecule that has lone pairs, if this were chlorine, then this would also be polar because it has a lone pair. So we want to make sure this is also polar, NH3. That's a very common molecule. So this is polar, but it fits in the very polar category because when hydrogen, the wimpy guy, is directly bonded to a nitrogen, then we have very polar. So this would actually move over here to this category.